Hello everybody again. We are going to continue chapter 8, strong acids and strong bases, the titration curve. What are the characteristics of such titration curves between strong acids and strong bases? We can see, as illustrated in this curve, there are three characteristic parts. Let's use the blue pen. Part A, B, part B, C, and part C, D. Here we see three parts. Part AB, part BC, part CD. The first part increases slightly in pH when the volume of the base is added from the burette. Why this slight increase? In this titration, when we add the strong base over the strong acid, H3O+, we add, say, 1 milliliter over 10 milliliters of this strong acid. This 1 milliliter, assume it consumes 1 milliliter of the strong acid. This corresponds to a certain number of moles. The number of moles included in 1 milliliter or contained in 1 milliliter of this strong base will react with the same number of moles included in 1 milliliter of this strong acid. Then the remaining is a strong acid. Here we are talking before the equivalence point, this one. Then the added solution is the limiting reactant, while the solution in the beaker is the excess reactant. That's why the remaining in this beaker before the equivalence point is acid. And this acid has a concentration that decreases with time upon adding the volume of the base from the burette. That's why the pH increases slightly in this way, slightly, till we reach the equivalence point, this one. When we reach the equivalence point, we can observe a sharp increase in the curve or a sudden jump. When one extra drop of the base is added after the equivalence point, in this case, the added base from the burette becomes the excess reactant, while the acid in the beaker becomes the limiting reactant. As we said before, at this point, the pH is 7. This is the pH of neutrality of this solution. Okay? When we add one drop of the base on the neutral solution at this point of pH, then the medium becomes basic, increasing. Now the curve shows a slight increase again. Why a slight increase again? When it becomes in this pH value about 9 or 10, the medium becomes basic in the beaker. Now when I add a base over a base, the solution becomes basic but more basic. Then the pH increases slightly again. So part AB slight increase, part BC sharp increase, while part CD slight increase again. Now, what are the characteristics, the other characteristics of such a titration curve? This titration curve is characterized by one inflection point. Only one inflection point. In the contrary to the titration curve, as we will see later, between a strong acid and a weak base, or a weak acid and a strong base, we are going to see in that curves two inflection points instead of one inflection point. It is a very important point that characterizes a titration curve between a strong acid and a strong base. Only one inflection point, and this inflection point at pH equal to 7. pHE, E means equivalence point, this one. At the equivalence point, the pHE is equal to 7. How can I determine graphically this point, this inflection point? We will see next right now.